All right, so in our video here, we're going to be looking at infinite limits, or what happens as we approach vertical asymptotes. So the definition of a vertical asymptote is that as you approach an x value from the left, the right, or both sides, that the outputs end up going to infinity. So graphically, what does that mean? If you approach some x value, let's call a over here, and let's just look at this first one, from the left. And if you notice the graph, as you approach a from the left, ends up trending up to positive infinity, or as you approach the graph from the right, trends down to negative infinity, then what that means is you must have a vertical asymptote at A. Same thing as we're going from the right, same thing if you're going from both sides. If you find your outputs are heading towards positive or negative infinity, as you're approaching a specific number, a specific x value, then there must be a vertical asymptote there. So the example that it gives in the text that I use for our videos here is looking at the graph of 1 over x minus 2 squared. So this is a shift of the parent function, 1 over x squared. It's moved to the right 2, and you can see in the graph that there's that vertical asymptote right there at x equals 2. Notice that as you approach 2 from the left, the values go to infinity. As we approach values from the right, our outputs go to infinity. So we can say, since it approaches infinity on both sides, as x goes to 2, our outputs approach infinity. We can say the limit as x goes to 2 of h of x goes to positive infinity. Now, some textbooks are going to go ahead and say that means the limit does not exist. Some say like it does exist and it's infinity. It all depends on the definition of the limit. So normally, in order for a limit to exist, it needs to go to a number, and infinity technically isn't a number value. So you can say that the function increases or decreases if it's negative infinity without bound, or that the limit trends to infinity. But a lot of books are going to say, therefore, the limit does not exist because the limit is infinity, or something of that nature. Let's look at two other parent functions. And we can kind of look at a table of values to think of why this is going to be true. So if I'm looking at 1 over x, and I want to look as x goes to 0. So let's do some x and then some f values. So a number left of 0 is going to be like -1. Well, if I plug in -1, 1 over -1 gives me -1. A number closer to 0 from the left might be like -1/2. Well, this is the reciprocal function. So 1 over -1/2 gives me -2. Let's get even closer to 0. So I need smaller negative numbers like -10. Well, the reciprocal of that number would be -10. I could get even closer to 0 from the left and say, let's go to -1,000. Well, the reciprocal of that is going to get -1,000. So notice as x gets smaller and smaller and smaller, f gets more and more and more negative, or is going to approach negative infinity. As we approach 0 from the right, the only thing that would make this different is now I'm approaching 0 from the right side, which means all of these values trend to positive infinity. Now, if we look at the graph of 1 over x, you then can see that that's true. We have a vertical asymptote at x equals 0. And here for C, we don't go to the same infinity value, so it is very clear that the limit from both sides does not go to the same infinity value. One goes to negative infinity, one goes to positive infinity. We say here the limit does not exist. In this next example, if you're squaring those negative numbers, so let's look at a table. So -1, you plug that in, you square it, you get a +1. You plug in -1/2, square it, reciprocal, we get 4. You plug in -1/10, square it, reciprocal, you get 100. So what ends up happening with 1/x² is our negative x values tend to go to positive infinity. If we go to +0, or I should say numbers to the right of 0, and all of these are positive, you end up getting the exact same mirrored output on the other side. And so we could say here that this limit, since both sides go to positive infinity, some books are going to say like, okay, it's okay to say positive infinity. However, also know that like that is not a number. So the actual limit does not approach a number. It does go to the same infinity side, but that's not going to be an actual number value. And because this is vertical asymptotes, know that because your outputs go to positive or negative infinity for any of these, that's the definition of a vertical asymptote. Again, if your x values approach a number and your outputs go to positive or negative infinity, that means you have to have a vertical asymptote at that x value.